All right, Hocus Pocus. I'm really excited because our next science unit is all about electric and magnetic forces. So you've learned about forces. Who can remind me what a force is? River. A push or a pull. And so we talked about how you can actually push something and make it move, and that's a force. So you can pull something and make it move, and that's a force. But remember when I took my marker and I dropped it and I said, oh, that's not a contact force, it's a non-contact force called gravity. Electricity and magnetism. Can you pull it together? Get your mask up. Have a seat. Electricity and magnetism, those are two more non-contact forces. So there's a quick video to get us started and kind of get your brains ready for our new unit, okay?
Hi, I'm Antonio, and I love robots. I was just imagining the type of robot I want to build. I want to be a robotics engineer someday. Robotics engineers build and test robots. There are so many things that a robotics engineer might do. Some robotics engineers create robots that do jobs that can be dangerous for people, like exploring the deepest parts of the oceans looking for shipwrecks or discovering new organisms. I want to build a robot that will explore volcanoes. I better get back to designing my robot.
Well,
Why do you suppose he talked about robots? What would that have to do with magnets and electric forces? Ellie? Ooh, tell me more about that. Who can add to that? Ellie said you got to do a lot of stuff to make your robots work. Brielle? Good. Brielle said since most robots are made out of metal, they're probably magnetic, or you might have magnets that help things work and move inside of them. Good. Cabot?
There might be a lot of spinny things to make it move.
Tell me more about that.
Like there's a thing connected to the engine and it like spins from the gas or electric, so it can hover.
Oh, so you're saying our robots are probably electrical, that they're running off of electricity?
Or gas.
Or gas, okay, yeah. River? Nope. Maddie? You waited too long, girlie.
Robots are made out of metal and they have electricity stuff in them because they need to run out of.
They're made out of electric.
Not always. They're made out of metal.
Maybe not always, but probably a lot of the time.
Plastic.
So,
There's
robots
plastic.
are one thing that can come to our minds when we think about electric and magnetic forces. I want to show you something else, and this might surprise you. So get your listening positions. Because this one I think might surprise you, that this also has to do with electric forces. And I want you to start thinking. I'm going to read it, and I want you thinking. Wait for a little while here. Why would this be in this unit? It's about Salma's hair. I'm going to zoom in a little bit on it for you.
Oh, electricity.
Salma rubbed a balloon on her hair. And then she held the balloon over her head. And Salma and her friends laughed when her hair went straight up and it stuck to the balloon. And they each had different ideas about why her hair went and stuck up towards the balloon. And here's what her friends are thinking. So I want you listening and thinking which friend you agree with, okay? Salma thinks that the balloon was acting like a magnet on her hair. So she's saying like the balloon would be like a magnet. When she held it over her hair would have clung to it out of magnetic force. Kurt thinks that the balloon and her hair are electrically charged. So he's saying that her hair got an electric charge, the balloon had an electrical charge, and so they're zapping together. Nikki thinks that the balloon is taking energy from the hair, and so it's making it stick out. Think about that.
Them all again.
If you agree with Salma and you think that it's through magnetic force, please stand up. Stand up if you think that it's because they had an electric charge. Both her hair and the balloon had an electric charge. Stand up if you think that the balloon was taking energy from the hair. Better. Okay, so we have lots of different things that we're thinking. Go ahead and sit down. Because I want to show you some vocabulary that might shift your thinking, or it might kind of prove what you were thinking before. Are you ready?
Do you have any balloons
That's
that
not
we
the
can
slides
test?
I wanted. Let me switch really quick here.
Do we have any balloons to test?
What's that?
Do you have any balloons that we can do it?
Ooh, we are totally going to do lots of experiments. One moment, guys. I got to shift my camera over here to my vocab. Not today. Today, I want you guys to learn about our vocab. So the big question in our new unit here, in lesson 1, is all about the electricity. So our question, who would like to read it for me?
How does
Savannah, loud and proud.
How does electric force affect objects?
How does electric force affect objects? Well, there's a lot of vocab that can go with this. The first one here is static electricity. Does anybody know what static electricity is? Miss Braylon. Yeah? Okay, good. And the static, have any of you ever touched something and it's almost like a zap from the static electricity? Yeah. How about this one? Who would like to read this vocab word? Kevin?
electricity changes?
Electrical. Good. An electrical charge. Think about something that has an electrical charge. Keegan? Say that again. Oh, yes. An eel, absolutely. Kevin, did you want to add to that?
We went to camp and we had like this globe where it has like electric,
Mm-hmm.
and we stepped on the stool, a plastic one, and once we stepped on it, we touched it, but it didn't shock us. But when we stepped off of it, it shocked us.
Interesting. I've got 2 more words I want to talk to you guys about to start off our unit. The first one is attract, and the next one is repel. These are opposites. Does anybody know what it means? If I wanted my fingers to attract right now, what would happen to them? Jade? They would come towards each other. If they're attracting, they would come towards and probably connect, right? What if they are repelling?
They would go apart.
Everybody?
They would go apart.
They go zoom, right? So those are my opposites. Friends, that is our vocab for our new unit. So I want you guys to be thinking this whole time. How does electric force affect our objects? If you've got an object, what are some electrical forces that can act on it? How can they attract or repel things? How can we build static electricity, or how can we give things a charge? And so we're going to get started today. I'm going to turn this off. We're going to get in our workbooks, okay? Please pull out your workbooks. Now this is your science workbook, the one that you actually write in. We are going to flip to page 54. What page?
54.
The one that you write in. So your purple science notebook workbook. Okay? 54. And it's got that picture of the balloon with Salma's hair.
54.
Mm-hmm. I want you to go ahead and notice that it says Salma rubbed a balloon on her hair. It's the same passage, but I want you to write down, who did you agree with most? Who did you agree with and why? Which person did you stand up for and say, this is the one that I think is correct?
You circle green.
I want you to write down. It says, who do you agree with most? And so you've got to read and say, did you agree with Salma? Did you agree with Kurt? Or did you agree with Nikki? And then jot down why you agree. And when you're finished, I'm going to give you about 1 minute to think about that. And then we're going to turn and talk to our neighbors and see what they think. See if you agree.
I have a question about electricity. When
Choose which one you agree with the most.
When you're on a trampoline and you're
Well, I
doing
think
like
it's-
this, you get like
Kevin?
When you rub your hand on it, and then you can shock other people.
Right now, you guys are writing it down. Who do you agree with most and why? That's what we're doing right now.
I already did. Right, but why you agree?
Mm-hmm.
What did Kurt say
Write this
again?
down first. Well, it said right there. Salma said, I think the balloon's acting like a magnet on my hair.
I got
Kurt said, I think the balloon and the hair are electrically charged. And Nikki said, I think the balloon is taking energy from the hair. Friends, even if you didn't finish writing down here, I wanted you thinking about it so that you were ready to talk to your neighbors. So when I say teach, I want you to turn and talk to your neighbors. Skylar, I'm going to let you pivot and talk with Jada and Kevin since Addison's gone. The rest of you guys, your partners, ready to go. So when I say teach, tell them who you agreed with. And I want you to use those complete sentences like, I agree with so-and-so because, and then prove why you think that they're right. Are you ready? Teach. Oh, we gotta try that again. Toss. How does that work? You don't have to have it written, you just have to have been thinking about it. Ready? Teach. Online friends, I'm going to be hopping back in and so that you can hear what some of these friends were thinking, but also I want you thinking about that. That's going to be something that I put in your slides for today. Who do you agree with and why do you think that they were correct? Good luck. All right, Tootsie Roll. Alrighty, my friends. I want to hear from one of my scientists who agreed with Salma. Do any of you think that the balloon is acting like a magnet, and why? Why do you think that, Rylan?
Because whenever I stick the balloon on my wall, it sticks on there. So I think our hair would stick to like on the balloon.
Kind of like magnets stick to magnetic things? Okay, very good. Do I have a scientist that agreed with Kurt? That you think that the hair in the balloon is electrically charged? Jade, let's hear from you.
So when you like put a balloon on your hair and it sticks, it's because that when you rub it, it's just a lot of static and it can't take it, so it just goes up like when like you're a person and grabs it. But it's like
So you use the word static. Do you think static has to do with being electrically charged? Ooh, maybe. Okay. Who agreed with my third person, Nikki? You think the balloon is actually taking energy from the hair? Sorry, guys. I'm going to move you all the way back here to Emerson. What do you think, Emerson?
I agree with Nikki because it has static electricity and energy helps the static electricity.
What do you mean energy helps the static electricity?
So if you rub the balloon on your hair, it gets so staticky that when you put your balloon over the head, it uses energy to help stick up onto the
Oh, so
balloon.
it's taking that energy so that it sticks up. Interesting thoughts. I'll be curious to see what you guys wrote. But I want you all to peek up here now at a picture. Are you ready?
Yes, we are.
Up here, there's another girl who's done this. That's not the right picture. Another girl who actually took a balloon and rubbed it on her head and made her hair stick up to the balloon. Have any of you done this in real life?
Yes.
Right? It's kind of fun to do, but I want you looking at this. And there's a question on the top of page 55 in your workbooks. It says, look at the photo of the balloon in the girl's hair. And I want you thinking, what's happening to her hair? Who can describe to me what's happening to her hair? And this is what you're going to jot on page 55 on those lines. What's happening to her hair, Riley?
Her hair is sticking up.
I love that you said that in a complete sentence. Her hair is sticking
What page is that on?
up. And it's just right on the next page is the top of page 55. There's those lines right there. Oh, it's in your workbook. You're adding this to your workbook
It
here.
says what question
Yep.
do you have?
So it says, what's happening? Her hair is sticking up. What am I missing from this, my friends?
Period.
A period at the end. Her hair is sticking up. Period. You guys can all jot that. Does anybody have something to add? Ellie?
Her hair is sticking up while her hair wasn't sticking up at first, but when she rubbed the balloon on her hair, it was.
Oh, so Ellie's noticing her hair's sticking out because of something to do with the balloon. So Ellie, if she moved the balloon instead of above her head, if she moved it beside her head, what do you think would happen to her hair?
Her hair would probably go sideways.
So can I change my sentence and add to it a little bit? I'll say her hair is sticking up. Should I put towards the balloon? Does that sound like a better sentence?
Yeah.
Okay, her hair is sticking up. Towards is a weird word, guys. It starts with two, T-O, and then wards, W-A-R-D-S.
It's
It's towards, but we just, in English, we're kind of a little bit lazy, and so we say towards, but it's sticking up towards the balloon, balloon, period. Her hair is sticking up towards the balloon. Now, I want to give you guys a moment to jot down any questions underneath that, because some of you might be wondering, I'm wondering what makes the hair do that. Anybody else wondering that? That's a question you would jot down. Some of you might be wondering, what will happen if she moves the balloon? How long will this last? Does it work for other objects? If I rub my marker against my head, will it work? So that may be, why does the balloon let this happen? But I want to give you a moment to jot down your questions. I'm going to set my timer for 2 minutes, and it's going to feel fast if you're really jotting. So how long do you have?
2 minutes.
2 minutes of silence. 2 minutes of silence. You need to come up with at least 2 questions.
Where?
Ready? On those lines. So you're putting them on the lines at the top of page 55. You're jotting down questions you have about what's happening here. Starting now.
That's what I said.
You've got to come up with at least 2 questions in your workbook, and I'm going to come around. You have 1 more minute here. Make sure those questions still start with a capital, but instead of ending with a period, they end with a question mark. Mm-hmm. I love it. Some of you are filling up those lines with questions. You're really using your scientific mind to start thinking, what's happening here? What do I know about electricity? What do I know about this static business? How can I stretch my brain and think even more about it? Focus, focus. That was 2 minutes. Who's got a question for me that I didn't write? Braylon. Ooh, what is making the hair stick up? That was kind of our Paige Keeley prompt, right? Like, all right, what's making it happen? Skylar.
Will it work on any balloon?
Will all balloons do this to your hair? Good question. Keegan.
Will other objects do this too?
Will other objects also, like if I take my marker and I rub it on my hair, is that gonna stick? Is there, what if I take a rub and I rub it against my hair, will it make it stick? What objects will make this happen? River.
What makes the hair do that?
Oh, okay. Jade.
Why does the balloon why does this to a balloon?
Good. Well, so why does it actually stick out, or why does it connect with the balloon? Riley.
If you look, so when you rub your hair on the balloon, and if you keep the balloon right there for a little while,
Mhm.
your hair falls down.
Ooh. If you've got more that you want to ask, whisper it to your neighbors for a moment while I show my screens. But I want you really asking yourselves questions. Somebody wanted to share their questions with their neighbors?
I do.
All right, focus. We talked a little bit about robots, but I want to talk to you about a couple, another career in electricity and magnetism. So I'm going to pause my video and restart here, but the career is going to be an electronics technician. What is the career? All right, let me zoom in here. Who would like to read about an electronics technician for me? Who wants to read that? Brielle, loud and proud. Oh, does anybody know an electronics technician in real life? Emerson? You know one in real life? I have a friend from college who he works at Google, and he does a bunch of electronic stuff to make sure that all of those machines are running right,
That's
and
your
they can do
friend?
all the right functions. This is not my friend, but I have a friend that's what they studied in college, was to be an electronics technician. Maddie?
My grandpa is because he works mostly on electronics always and he helps on Wi-Fi and all that.
Cool. Riley?
My dad works at a place.
Very cool. There's more than just that. Let's read a little bit more. On page 55 in your workbook, I'm going to shift this. And it's right under where you listed your question. So it's in that yellow notebook bit. It says, read about the electronics technician and answer the questions on the next page. So I want you to follow along as I read a little bit here about Grace, because she is a computer programmer. What is she? A computer programmer. That's a type of electronics technician. So follow along because you guys can plug in the blanks as I read. Are you ready? Oh, that was weak. Are you ready?
Yes, we are.
Okay. Today we are building new computers in a clean room. This room must be free of dust, hair, lint, and static electricity to protect the equipment. That means I must wear a special shoe covers, face mask, and hairnet while working in there. These clothes will help me keep the room as clean as it needs to be. Once this project is done, I will be reviewing and repairing the electrical and computer equipment to keep everything running smoothly. Maintenance is a large part of my job. If electricity or computers go down, many people are not able to work. So every day, I am reviewing, repairing, and maintaining something. And Grace, our programmer here, says electronics technicians need to understand how electricity and can solve problems. Did you guys know that you actually don't want to put magnets by your computers?
Yeah.
Because like you guys told me, a lot of robotics and a lot of machines are made out of metal, and they're tiny little metal pieces, and so if you have strong magnets by it, what do we know about what could happen
It'll
to the
pull
metal?
it out of place.
It could shift things and pull them out of place, and then those machines might not run properly. So reading about this, on the next page we're going to answer some questions. So please turn your page. Okay, again, friends. Turn your page. Turn your page. Turn your page. Turn your page. Why must the room be free of dust, hair, lint, and static electricity? And if you don't know the answer, you should be flipping back and trying to find it there. It was in the second sentence. Who can find it? Why must the room be free of dust, hair, lint, and static electricity? Macy. Yeah, specifically, what are the words they used? Instead of saying to keep it safe, they said to protect the equipment, but she's absolutely right. To keep the equipment safe. And we're going to use that word equipment in here. So it's E Q U I
Q U I
P M E N T. To keep equipment safe. And I'm letting you guys do short and sweet answers here, but we do want that word equipment. Equipment includes anything that goes into the technology. You guys might be interested to know that first picture where that guy was peeking through the computer, like all the silver stuff. We have a room like that here in our building, and it is a special room. They had to put, nope, actually it's off of Susan's office, but it's a special room that there's a special type of flooring so that when they walk in there, it doesn't build static electricity. And there was like a big deal when they like helped remodel our building and put all the computers in there. They had to make sure there was good air conditioning so they didn't get too hot. We can't because we would bring in our hair and lint from our clothes and static electricity and dust. And because we don't have that special clothing, right? So it's not our job to go in there. We've got special people who take care of that, and those people's job would be an electronics technician, right? Yeah. Class. Why is maintenance such a large part of the electronics technician's job? If you don't know it, go back and try to find it. There's a sentence that says maintenance is a large part of my job, and then it follows with why. Why is that a big deal? Why is it so important for them to maintain things? And to maintain it means they've got to keep it up. They've got to make sure that it's running in tip-top shape. For example, my dad is the maintenance guy at Omaha Steaks, and one of his jobs is to make sure that the freezers are working. Because if all of their meat is in freezers and a freezer breaks, it's not keeping that meat cold, right? So he has to maintain those machines and make sure they're going. Or if a door, just like teachers have to log in with our badges, that's how my dad's work is. And if one of the doors, if the computer system on that isn't working, he has to reprogram the door so that people can get into the building. Why is that a large part of their job, Keegan? Yeah, what did they say in their sentence? They said, if we find our answer here, because we're going to use that evidence, maintenance is a large part of my job. Aha. So why is it so important? Why is it such a large part of their job?
So they can
If electronics go down, many people can't what, Keegan? Many people can't work. It's kind of like, you guys remember how frustrating it was when you were supposed to do your Kahoot and the code wasn't working? Remember how frustrating that was? And then we ran out of time and we couldn't do it? It's kind of like that. If the electronics aren't working,
They won't have our assignments.
then it can't work. Oh yeah, people. Good. That's kind of a big deal. If people work at these places, they have to be able to do their job. So again, to wrap up for today, friends, I want you thinking about that essential question here on page 56, and it says, how does electric force affect objects? We're going to keep reading. We're going to do a lot of experiments. Don't worry, we will be pulling out balloons. I know Dax was peeking at the next page and said, hey, are we going to do this? You bet your bottom dollar we are. We're gonna do quite a few actually. The experiments are very fun in this unit. But the whole time I want you thinking, how do electric forces affect objects? Or how does electric force affect objects? That's all we have for today. Online friends, make sure that you check your slides. So I'm gonna have some of these questions for you to fill out and be thinking about them so that you're ready for our experiments coming up. Good luck.